To prove the Isosceles trapezoid theorem, we must first know what specifically we are proving. In this case, it is that these two base angles are congruent. With that out of the way, let's begin. Let's begin by extending each of these sides out to better illustrate the parallel line theorem. According to the parallel line theorem, a non-perpendicular line connecting two parallel lines creates congruent corresponding angles and congruent alternate exterior angles, shown here. The next step requires a little bit of explanation. Since this is an isosceles trapezoid, the two non-parallel sides are congruent. Therefore, both transversals have congruent corresponding angles, shown here. So, if we flip this line right here, it will show how the base angles are congruent. Now, if we take away these lines, we can see how the base angles of an isosceles trapezoid are congruent. The formula of a trapezoid is relatively basic. The area equals a plus b divided by 2 times h, where h is the height and a and b are the top and bottom sides respectively. Now let's break this equation into two parts. The first part of this equation is a plus b divided by 2. This part of the equation is effectively finding the average of the two sides, seeing as it follows the same formula as averaging numbers, simply adding the numbers and dividing by the amount of numbers. Now, the second part of the equation. Now we're going to find the rest of the formula. To do this, we are going to compare this formula to that of a rectangle. We've already done half of this by finding the average of the two bases. To find the area, we will basically copy the second part of the area of a rectangle formula. With the formula of a rectangle being area equals base times height, we'll simply multiply this by the height.